what's up guys? Day 49. We're getting down to the nitty-gritty here. We are approaching our exam on Monday. So nice thing is, if you're watching this video on Saturday, you got a lot of time to prepare, a lot of time to go through your note cards, make sure you got your definitions straight, make sure your understanding is really good. Okay. So keep checking that throughout the weekend, maybe Monday morning on the bus ride in. Double check, read through things, make sure you're good to go. And I want to focus on problem number 22 here. Here we see a graph of f prime. It says, this is a graph that I pulled from a previous free response question from AP Calc. It says the graph of f prime, the derivative of f on the interval from -6 to 5. We have f prime is made up of 3 line segments and a semicircle. Question A says, what are the x values of the critical points of f on the interval from -6 to 5? One thing I want you to see about that interval, notice how that's a soft interval from -6 to 5. So we're not going to include -6 or 5 in our answers, just anything in between them. Determine each critical point is a relative min, relative max, or neither. This is like absolutely crucial to be able to tell our relative mins and maxes, or neithers, right? Find our critical points based on a graph of f prime. So again, I want the critical points of f. Critical points of f are when f prime equals 0. So taking a look at my graph here, I see f prime values of 0 at -2, at +2, and at 5. However, I can reject x equals 5 because it's not in the interval, right? That goes up to, but does not include x equals 5. Okay, so here's what I need to do, right? I'm going to report each critical point and determine if it's a relative min, max, or neither. So let's start with, I always work left to right. I'm going to start with x equals -2. X equals -2 we know is a critical point because f prime equals 0 at x equals -2. What I want to do now is determine, is that critical point give us a max on f, a min on f, or neither? Well, to determine that, I have to determine how does f prime change at x equals -2. Well, to the left of -2, f prime was positive. It was above the x-axis. That means f was increasing until it hit -2. Then f started decreasing because f prime went minus, right? So on the left side here, we know f prime is plus. On the right side, we have minus. That tells us that f has a relative max. So x equals -2 is a relative max. My justification is because f prime switched from plus to minus. Anytime we see an f prime graph, those zeros are going to be very, very important. Those are my critical points of f, right? They're critically important. And on those zeros, I can determine if it's a max or a min or neither based on how f prime changes at those zeros. Okay? How about x equals 2 there? Well, at x equals 2, once again, I have f prime equaling 0, but this time f prime is switching from a negative value to a positive value. So that's going to be a relative min. So I can say x equals 2 is a relative min because f prime switches from minus to plus this time. Just like when you had a function f of x, right? It was one of the videos I did probably on Monday or one of the previous couple videos ago. We were finding relative mins and maxes, but we weren't dealing with an f prime graph. We were dealing with a function f of x, right? We found f prime, we found the zeros of f prime, then we made a number line. And again, we were testing to see how that number line changed. Did f prime go from plus to minus, minus to plus, or did f prime not switch signs? Good. B is a tough question here because it's asking for an interval, but an interval where 2 things are happening simultaneously. So the question here says, on what intervals is f both concave down and increasing. Okay, so I just want to report the intervals where f is simultaneously concave down and increasing. So f is both concave down and f is increasing. Well, whenever I have these combo, I call them the combo platter. Whenever I have these combo platter type questions, what I like to do is focus on the increasing, decreasing part first to narrow down my choices. Okay, so I'll worry about f being concave down in a second. I want to first worry about f increasing. I know f increases whenever f prime is positive. So what I do is I take my finger, this is kind of hard to show in the video, but I take my finger and I cover up the semicircle that lies below the x-axis there. Okay, so it would look something, if you follow my mouse here, I would take my finger and cover up the whole bottom part of this graph here. Because when f prime is negative, f is decreasing, right? So that fails the increasing part. So looking at that line segment on the left and the little triangle thing on the right, now I want to determine, just looking at those two pieces of the graph, where is f concave down? Okay, so once again, I have to know my definitions here. F is increasing whenever f prime is greater than 0. F is concave down, right? So that's why I covered up that section of my graph. F is going to be concave down when f prime is decreasing. So just looking at the points, or the parts of the graph that are above the x-axis, where are those graphs f prime decreasing? Well, the whole left side is, right? From -6 to -2, f prime is both greater than 0 and going down. I will also have that same stretch from 3 to 5. So I'm going to say from -6 to -2, union 3 to 5. And my justification is exactly what I'm looking for in my definition. That's where f prime is decreasing. By the way, I put my answers in the same order that it was asked. They asked about concave down first, then increasing. So I'll give my concave down definition first, then my increasing second. Because that's where f prime is decreasing and positive. Or you can say that's where f prime is decreasing and f prime is greater than 0. Okay. Next questions got cut off, so I'll write them. C is for f double prime of -2, f double prime of 4. I want to find value or state that it does not exist. Or state why it does not exist. Okay. Now this is tough because they just asked about f double prime, but we don't have an f double prime graph, we have an f prime graph. So what I want to do is I want to think about, well, how do you go from f prime to f double prime? Well, the answer is obviously you do a derivative, right? Well, I don't have a function to do a derivative of, so I want to think about the meaning of a derivative. Derivative is simply the slope of the tangent line at that point, right? It's the instantaneous slope. So this is a question about the slopes of my f prime graph at -2 and 4. Now, sometimes we can find these slopes, sometimes we can't. Let's start with -2. That's right here on the graph. I cannot find an instantaneous slope at x equals -2 because the slope is different when I look to the left of the point and to the right of the point. Right? So f double prime of -2 does not exist. And we can say because f prime has a corner there. So f double prime of -2 does not exist because the f prime graph has a corner there, a point where we can't do a derivative. Okay. 4 is going to be better though for us. 4 is right here on the graph. And I notice that has a consistent slope on both sides, right? And it's simply the slope of that segment that connects the 0.32 to the 0.50. So I want to know, what is the slope of that line? Now, here's what a lot of people do. They do rise over run, and then they get an answer of 1. Okay, you got to be very careful here. We need to consider the sign. That slope is for sure a negative slope, right? We just reported it as f prime was decreasing there, so f double prime should be negative. Okay, so what I do is I do rise over run, and I say, okay, it goes down to over 2, and that gives me an answer of negative 1. So f double prime of 4 equals negative 1. Okay. Good. And then part D asks for the inflection points. Do you want the inflection points of f? Okay. So inflection points of f, right? We know two different definitions. It's when f prime goes from increasing to decreasing or vice versa. We also know it's when f double prime switches signs. Well, obviously we want to use the f prime. We want to think about this in terms of f prime because that's the graph we have, right? So I want to look on my graph and see where does f prime switch from increasing to decreasing or vice versa. So when I look up at this graph, I notice that f prime starts off decreasing, right? So I'm just going to kind of trace this in yellow. F prime starts off decreasing, 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 decreasing. It hits that weird corner, but stays decreasing, 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 until I get to an x value of 0. When x equals 0, on the right side of 0, f prime is going to start increasing. And then I'm increasing, 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 increasing. Kind of a weird point, but I keep increasing, 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 decreasing, decreasing, decreasing. When did I switch from increasing to decreasing or vice versa? Right here and right here. Those are my 2 points, x equals 0 and x equals 3. Because, those are my inflection points because f prime switches. I always report the one for 0. 0 was my leftmost point. So 0 went from decreasing to increasing, so I'm going to say that first. F prime switches from decreasing to increasing. Or vice versa. Okay. So 0 and 3 were my 2 inflection points there. One last thing before I go here. I just want to sketch a graph of f prime. When we look at a graph of f prime, we should be able to identify a lot of stuff right away. So, let me just make one up here. Okay. Okay, so let's say that this is a graph of f prime of x. Okay. Right away, what are my critical points of f? Well, by definition, critical points are when f prime equals 0. When does this graph equal 0? Well, we see -4, we see 3, and we see 12. What types of critical points are those? Well, -4, f prime switches from minus to plus. That's a min. We should be able to look at this right away, say, that's a local min. That's a local max. And that's a local min. We need to be 100% automatic with that every single time. No mistakes whatsoever. So we have local min at -4, a local max at x equals 3, and a local min at x equals 12. How about inflection points? Well, that's when f prime switches from increasing to decreasing. That happens right here. Inflection point. And here, inflection point. So those are the places where f prime switch from increasing to decreasing or vice versa. Do I have any neither critical points that are neither? No, because I don't have any zeros where we didn't actually cross the line. If I ask you quickly, when is f increasing? Well, that would be easy. We'd say from -4 to 3, union 12 to 13, because that's where f prime is positive. Where is f decreasing? Easy. From -7 to -4, union 3 to 12, because that's where f prime is negative. How about this? Where is f concave up? F is concave up from -7 to -1, union 8 to 13, because that's where f prime is increasing. Where is f concave down? Easy, from -1 to 8, because that's where f prime is decreasing. Okay? So again, f prime being positive or negative tells you whether or not f is increasing or decreasing. F prime increasing or decreasing tells you whether or not f is concave up or concave down. Okay, that's it for today. If you have any other questions, let me know. I should be in early on Monday. I'll be in the room probably around 7:30. So if you have any last-second questions, ask them then. Check the key online. Have a great rest of your weekend. 2 chains. Bye.